All right, so we are looking at systems of linear equations in two variables. So these are straight lines that have a solution of an ordered pair that satisfies both equations in the system. So we're looking to determine if each of the ordered pairs is a solution for the system. So we have x plus 2y equals 2 and x minus 2y equals 6. So what we're going to do with that, we have 2 points. We're going to plug them in and see if we get a true statement. So 5.1, and we are looking at example 1. So x plus 2y equals 2, and x minus 2y equals 6. So the first ordered pair that we're looking for is 4, negative 1. So this is our x value, this is our y value. We're just going to plug them in. So we're going to have, in our first equation, we'll have 4 plus 2 times negative 1 equals 2, which gets us 4. 2 times negative 1 is negative 2. So 4 minus 2 is 2 equals 2. It works for the first equation. Now let's check the second one. So we have x minus 2y equals 6. So 4 minus 2 times negative 1 equals 6. We have 4. Negative 2 times negative 1 is positive 2. 4 plus 2 is 6. 6 equals 6. So yes, this one will work. It is true for both, so this one works. It is a solution for the system. All right, let's look at the other point. So our other point is negative 4, 3. So we're going to do the exact same thing we did over here. So for x plus 2y equals 2, we have negative 4 plus 2 times 3 equals 2. So negative 4 plus 6 equals 2. Well, 6 minus 4 is 2 equals 2. It works for this one. And then we have x minus 2y equals 6. So negative 4 minus 2 times 3 equals 6. Negative 4 minus 6 equals 6. Well, negative 4 minus 6 is negative 10 equal to 6. Ooh, that's not a true statement. So this is not a solution for our system. So you could also, another way to see if these worked, you could graph both problems. You could solve them for y equals mx plus b, or pick some points and plot. You could graph it, the x plus 2y equals 2, and the x minus 2y equals 6, and you can see where they intersect. So the point of 4, negative 1 is where they actually intersect. So that's another way you can solve by graphing the two problems. So you can, like I said, solve it for y equals mx plus b, or pick some points and draw your lines. Just be careful when you're doing that so that you actually get an exact part there on the graph. You can also solve by substitution. You need to solve either of, that should be solve, either of the equations for one variable in terms of the other. Substitute the expression found in step 1 into the other equation, the result in an equation in one variable. Solve the equation containing one variable, and then back substitute what you found, and then check your proposed solutions. So let's go do an example with solving by substitution. So this will be example 2. And this is solve by substitution. So if we're looking at the ordered pair, the system of equations, so 5x minus 4y equals 9, and x minus 2y equals negative 3. So if we want to substitute, we've got to solve one of the equations for a variable. So between these two equations, the easiest one would be to do this equation and solve it for x. So I'm going to solve for x on x minus 2y equals negative 3. So I'm going to add the 2y to the other side. and get x is equal to 2y minus 3. Now that I have this equation, I can substitute that back into the original. So I'm going to substitute using this, what my x is, into this equation. So we have 5x minus 4y equals 9, but we know that x is equal to 2y minus 3. So that'll give me 5 times 2y minus 3 minus 4y equals 9. So now what we want to do is distribute our 5 times our 2y minus 3. So 5 times 2y is 10y. 5 times negative 3 is negative 15 minus 4y equals 9. Combining like terms, I have 6y minus 15 equals 9. I'll add my 15 to the other side, and we end up with 6y is equal to 24. Divide by 6, and y is equal to 4. Now that we know the value of y, we can plug it back in to the other equation and see what we find for x. So now we're going to sub y equals 4 into x minus 2y equals negative 3. So x minus 2 times 4 equals negative 3. So x minus 8 equals negative 3. Add our 8 over, and x will equal 5. So my answer will be 5, 4. And it's an ordered pair. It is your x and your y. Make sure you put them in the right order. You can check to see if your answers are right. You can go back and plug them into the original equations, to both of them, and make sure what you get is actually a true statement, just like we did on the very first problem, where you now know that it is truly what's going on. All right, the next type we're going to look at is solving by addition. So solving by addition, we're going to make sure both of them are looking the same in the equation, and we might need to multiply both sides by a number to get, we're basically looking to cancel something out. So if you're in my class, you have the handout, and if not, we're going to go over the same thing through those steps. So let's look at example 3. So example 3, we are solving by addition. And as we look at solving by addition, we're looking at this system here. So we have 3x minus 4y equals 11, and negative 3x plus 2y equals negative 7. So the first thing you want to do is look at your equations and see if I just add them the way they are, will something cancel? Well, in this case, if I add these two equations together, my 3x minus 3x would actually go away. So I don't have to do anything. I just need to add to cancel my x. So I'm not going to rewrite them. I'm just going to add right here. So 3x minus 3x leaves me with 0. Negative 4y plus 2y will get me negative 2y. And 11 minus 7 will get me 4. Divide both sides by negative 2, and we get y is equal to negative 2. Now I'm going to substitute back in my y is equal to negative 2. And I think I'll choose the first equation just because my x is positive there. And when I multiply by that negative 2, that'll make it positive. You can do either one. You'll get the same result. So 3x minus 4 times negative 2 equals 11. So 3x plus 8 equals 11. Subtract the 8 over, and you end up with 3x is equal to 3. Divide by 3, and x will be equal to 1. So my solution will be 1, negative 2. It's again an ordered pair of x comma y. Now that was a simple solve by addition. We're going to do another one that'll be a little bit more complicated because they're not just going to cancel from the very beginning. All right, so example 4, we're still solving by addition. We have a system of 3x plus 2y equals 48 and 9x minus 8y equals negative 24. So we're looking at which variable we want to cancel. You have to have a positive and negative like we did in the previous example. So I have a positive and negative here. So I think I'm going to cancel y because I don't have to multiply by a negative value. I can just multiply by a positive. So to cancel out the y's, I have negative 8y. I have to look at this and see what will I multiply 2y by to get to negative or to get to positive 8 so that they'll cancel. Well, I just have to multiply by 4. So I'm going to bring my equation over here and I'm going to write multiply by 4 in shorthand there so I know what I'm doing with each equation. And on this one, there will be no change. You don't necessarily have to write all of the way that I do it, but I found it a little bit easier to follow when we do it this way. So that means we're multiplying everything. So 4 times 3x will get us 12x, 4 times 2y will get us 8y, and 4 times 48 will get us 192. No change means I'm just bringing this one over just the way it is. So 12 plus 9 will get us 21x. My y's will cancel, and 192 minus 24 will get us 168. Divide by 21, and x will get you 8. So now that I have my x value, I can actually sub that back in to one of my equations. So I'm going to sub x equals 8. I'm probably going to choose this one because the numbers are smaller and my y is positive. So I'm going to use my 3x plus 2y equals 48. So 3 times 8 plus 2y equals 48. So that'll get me 24 plus 2y equals 48. Subtracting the 24 gets you 2y equal to 24. Divide by 2, and my y will equal 12. So my solution will be 8, 12. Again, it's an ordered pair, so order does matter on this. All right, so the next problem we're going to look at, it's not going to be as friendly of a problem, but it could show up in your homework. All right, we're looking at example 5. So example 5, we have the system of 2x minus 7y equals negative 17, and 3x plus 5y equals positive 17. So again, we need to cancel one of our variables out. So I'm going to cancel, we could either go with x or y, but I'm going to go ahead and cancel the x this time because last time we canceled y, so I want to show you different ways you can do it. So I'm going to have to make one a negative that I multiply by and one a positive. So I'm going to multiply the top one by the negative so I can make these all positive. And then this one I'll multiply by the positive. So I'm going to have to multiply each equation by something. So I'm going to multiply by negative 3 because I need this to be a negative 6 and this will be a positive 6. And the bottom I'm going to multiply by positive 2. So when I multiply by negative 3, I'll get negative 6x plus 21y is equal to positive 51. Now I'm multiplying this one by positive 2, which will get me 6x plus 10y equals 34. When I add these, my x's go away. I end up with 31y equal to 85. Now when I divide both sides by 31, I get y is equal to 85 over 31. Well, that's not a very fun answer. I do not want to plug 85 over 31 back into one of these equations. It's not a whole number, it's a fraction. So what I'm going to do is I'm going to go back to my originals and I'm going to solve for y, or for x. So I'll cancel out y. So going back to the original equation, I'll have 2x minus 7y equals negative 17, and 3x plus 5y equals positive 17. So now I'm going to multiply the top one by 5 and the bottom one by 7. So multiply by 5 and multiply by 7. So multiplying by 5, I will get 10x minus 35y is equal to negative 85. Multiplying by 7, I get 21x plus 35y is equal to 119. So this will get me 31x, my y's will cancel, equal to 34. Divide both sides by 31, and x will be equal to 34 over 31. So my ordered pair will be 34 over 31, comma, 85 over 31. So not a pretty one, and if you end up with something, you won't have too many of those that'll show up. I'm certain in your homework and that, but if you do, always double check your math or go do the other one and see what you get. All right, sometimes we will end up with no solution or infinitely many solutions. So if we end up with exactly one ordered pair, that's where those two lines intersect that we talked about at the beginning. No solution means we have two parallel lines because they will be parallel and they'll never cross, so they don't have a solution. Or we could have infinitely many solutions. So that means we have two identical lines that are right on top of each other. They are two lines and they're going to, everything intersects on them. So you will have infinitely many solutions that happen there. Alrighty, so let's go look at some of those. So example 6, we are looking at the system of 4x plus 6y equals 12 and 6x plus 9y equals 12. So let's cancel x in this case. X has a little bit smaller numbers than y. So that means I got to multiply one of them by a positive and one by a negative. I'm going to multiply the top by the positive and the bottom by the negative. I can't just do, like on the last one I had 2 and 3, so I used 3 and 2, but this one I have 4 and 6, so I need to figure out what is their common multiple. And you want the lowest one. I don't want to multiply by 6 and 4 if I don't have to. They are both multiple, or they have a multiple that is 12. They're both divisible into 12. So 4 times 3 will get me 12, and 6 times 2 will get me 12. So in this case, I'm going to multiply by positive 3, and on this one, I'm going to multiply by negative 2. So 3 times 4 is going to get me 12x. 3 times my 6 will get me 18y, and 3 times 12 will get me 36. 6 times negative 2 will get me negative 12x. Negative 2 times 9 will get me negative 18y. And negative 2 times 12 will get me negative 24. So now when I subtract, my x's will go away. Uh-oh, my y's went away. I have nothing left over here. But I have 0 equal to 12. Well, 0 does not equal 12. That is a false statement Because if we're looking at 0x plus 0y equals 12, well, if we don't have any x's, we don't have any y's, it can't equal to 12. So this is no solution. So whenever it is a false statement, because 0 does not equal 12, then that's when we know it's a no solution. All right, let's look at example 7. So for example 7, we have negative 3x plus y equals negative 2, and we have 15x minus 5y equals 10. So if I'm looking to cancel y, because y is my smaller numbers here, I can multiply this y by 5, and I'd have 5y minus 5y. So we'll multiply by 5, and this one will be no change. So this will get me negative 15x plus 5y equals negative 10. And this one's a no change, so 15x minus 5y equals 10. So x's cancel, the y's cancel, we have 0, but 10 minus 10 is 0. Oh, 0 equals 0. That is a true statement. And this is infinitely many solutions. So this has infinitely many solutions, because one side equals the other. If you start to look at the problem, you'll notice that this is a multiple of negative 5 to each part. So how would you write the solution? On this one, you're going to write it as x, y, such that you can pick either equation. Negative 3x plus y equals negative 2, or you can do the xy's such that 15x minus 5y equals 10. So that means you would just pick x and a y. You can, they're going to get you just a line. You can solve it for y equals mx plus b. There's lots of things you can do. But you're saying for this equation, whatever you plug in or figure out, it will be infinitely many solutions. All right. So that's example 7. Let's go look at example 8. So example 8 is a word problem. So we are looking at a hotel has 200 rooms. Those with kitchen facilities rent for $100 a night, and those with kitchen facilities, without kitchen facilities rent for $80 a night. One night when the hotel was completely occupied, revenues were $17,000. How many of each type of room does the hotel have? So when you're looking at these, you have to look at the totals. The totals are going to give you some clues. So you're looking at, we've got kitchen and no kitchen equals the totals. So first of all, let's look at our rooms. We have 2 types of rooms. You need to pick 2 variables. Most of you like x and y, so x plus y, the total number of rooms they said we have are 200. And now we're going to do the rooms with the cost. So the cost of the kitchen room is $100. So 100x plus the cost of the no kitchen room is 80, so 80y. And the total that we ended up with was $17,000 is what they made for revenue. So now we're back to solving a system. This is our system. So we're going to do the same things we did in the previous problem. So let's cancel y, because y is smaller than the 100. So we're going to, or you could do the x, it doesn't matter. So here we're going to multiply by negative 80, and then this one will be no change. So we'll end up with negative 80x minus 80y is equal to negative 16,000. And then no change is 100x plus 80y equals 217,000. Add them together, and you end up with 20x. Y's cancel. 17,000 minus 16,000 will leave us with 1,000. Divide by 20, and x will be equal to 50. So that tells us that we have 50 kitchen rooms. Now we need to find how many no kitchen rooms. We can go back to this equation and we can sub x equals to 50 and our x plus y equals 200. So we have 50 plus y equals 200. We'll subtract our 50 from both sides and get y is equal to 150. So that tells us that we have kitchen, we have 50 rooms, and no kitchen, we have 150 rooms. And 50 and 150 would be 200. All right, example 9 is another word problem. We have a theater that sells adult tickets for $14 and children tickets for $9. A total of 486 tickets were sold, totaling $62.19. So we're going to do the same thing here on example 9. So we have the adult plus children is going to equal your totals. So again, you can pick any variable you want, but I'm going to still use x and y. So x plus y equal the total number of tickets of 517. Oh, nope. So 517 and 18x plus 9y, because I think I changed the values on the handout. Okay, so 18x plus 9y equals 62.19. Let me do a quick check here. All right, so these are our two systems of equations. So we're going to get rid of the 9s. So we're going to multiply by -9, and here we'll have no change. So we are looking at -9x minus 9y equals -4653. And then 18x plus 9y is equal to 62.19. When we subtract, we'll end up with 9x, the y's go away, and we have 1,566. We'll divide both by 9, and x will equal 174. So now we're going to sub back into... We will sub our x is equal to 174 back into here. So x plus y equals 517. So 174 plus y equals 517. We'll subtract the 174. And we get y is equal to 343. So that means we have 174 adult tickets and 343 children tickets. And I will update my handout. Apparently there's some typos in there. So if you're in my class, you'll find that the handout you have now is updated.